Hello students, this is Dilip and today I will teach you one topic of first order differential equations, that is ordinary differential equations of first order and higher degree. If the degree of dy by dx in a differential equation of first order is higher than 1, it is convenient to denote dy by dx by small p. Hence, a differential equation of first order and higher degree can be written as function of x, y, p equals to 0. There are three cases of such equations: equation solvable for p, equation solvable for y, and equation solvable for x. We will see case number 1 first, equation solvable for p. So let small p raised to n plus capital P1 into small p raised to n minus 1 plus capital P2 into small p raised to n minus 2 plus dash 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 plus capital Pn equals to 0. Here small p is dy by dx. So this is first order differential equation and its maximum power is n. So this is first order differential equation of nth degree. Okay, be an ordinary differential equation of first order because small p is dy by dx. Okay, and nth degree and its maximum power is n, where p is dy by dx and capital P1, capital P2 up to capital Pn are functions of x and y. Now we will see examples related to this topic. Solve x square equals to 1 plus p square. As this is the problem of case number 1, that is equation solvable for p, we will make subject of p from this equation. So we have p square equals to x square minus 1. So p will be plus minus square root of x square minus 1 and p is dy by dx, that is equals to plus minus square root of x square minus 1. Now applying the concept of variable separable form, we have dy equals to plus minus square root of x square minus 1 dx. Integrating both sides, we have integration dy equals to plus minus integration of square root of x square minus 1 dx. Integration of 1 with respect to y, answer is 1, plus minus as it is, and integration of square root of x square minus 1. The result is x by 2, this same function, that is square root of x square minus 1. And after minus sign, a square by 2, and the value of a square is 1, so it will become 1 by 2 into logarithm of x plus this same function, that is plus square root of x square minus 1 plus c. This is the general solution for given differential equation. Now moving on to example number 2, we have to solve this differential equation x square p square plus xyp minus xy square equals to 0. So first of all, we will factorize this differential equation. We will find out two numbers such that their product is 6 and their subtraction is 1. We will split the middle term. So first term x square p square will be as it is, minus 6y square as it is, and splitting 1xyp as plus 3xyp minus 2xyp. Now taking px common from these two terms, into bracket we have px plus 3y. Then after taking minus 2y common from these two terms, into bracket we have px plus 3y. This is equals to 0. So in one bracket we have px plus 3y, and in second bracket we have px minus 2y equals to 0. So we will be having px plus 3y equals to 0 or px minus 2y equals to 0. X as it is, and we know that p is dy by dx plus 3y equals to 0. Now we will solve this differential equation. Applying the concept of variable separable form, we will be having dy by y plus 3 by x into dx. This is equals to 0. Now integrating both sides, integration of 1 over y, answer is log y, plus 3 as it is, integration of 1 upon x, answer is log x, equals to constant value log c. So log y will be as it is, plus applying the property of logarithm, it will become logarithm of x cube equals to log c. Again applying the property of logarithm, log x plus y, log x plus log y equals to log xy. So it will become log y x cube equals to log c. Now both side log will cancel out. We have y x cube equals to c. Now similarly, repeating the process for px minus 2y equals to 0, x as it is, p is dy by dx minus 2y equals to 0. Now again applying the concept of variable separable form, dy by y minus 2 by x into dx equals to 0. Integrating both sides, integration of 1 over y, answer is log y, minus 2 as it is, integration of 1 over x, answer is log x, and that is equals to log c. Log y minus applying the property of logarithm, it will become log x square equals to log c. Now again applying the property of logarithm, log x minus log y equals to log x by y. So it will become logarithm of y by x square equals to log c. Now log will be eliminated, so it is y over x square equals to c. So the general solution is, from here we will get yx cube minus c, yx cube minus c, and from here we will get y equals to cx square, so we will be having y minus cx square equals to 0. So this is the required general solution, that is yx cube minus c into y minus cx square equals to 0. Now we will see case number 2, equation solvable for y. So this is example number 1. We have to solve this equation, y equals to 2px minus xp square. So y equals to 2px minus xp square. Suppose this is equation number 1. Now we will differentiate this equation with respect to x. So it will become dy by dx, and dy by dx it means p. Now derivative of 2px according to product rule, 2p same, derivative of x is 1, then after plus 2x same and derivative of p is dp by dx, then after again applying the product rule over here, minus p square as it is, derivative of x is 1, then after minus x as it is, derivative of p square is 2p into dp by dx. Then after we have to simplify this equation. You can see that this is plus 2p and this is plus 1p. So plus 2p minus 1p, the result is 1p, and over here from this term and this term, you can see that we have common term, that is 2x dp by dx. Okay, so into bracket we will be having 1 minus p, and this minus p square will be as it is, and this is equals to 0. Now taking common p from p and minus p square, so into bracket we have 1 minus p plus 2x dp by dx into 1 minus p will be as it is, that is equals to 0. Now taking 1 minus p common from this first term and this second term, so in one bracket we have 1 minus p, and in second bracket we have p plus 2x into dp by dx. We have to neglect this second factor because this term does not contain dp by dx. So we have p plus 2x dp by dx equals to 0. Now applying the concept of variable separable form, it will become 2 dp by p plus dx by x equals to 0. Now integrating both sides, we have integration 2 dp by p plus integration dx by x equals to 0. Integration of 1 over p, answer is log p, 2 as it is, plus integration of 1 upon x, answer is log x equals to log c. Now applying the properties of logarithm and simplifying the result, we have p square into x equals to c. So we will be having the value of p square, that is equals to c by x. Now say this is equation number 2. Now from equation number 1, right, we have equation number 1. that is this one, y equals to 2px minus xp square. We have y plus xp square equals to 2px. Now squaring this above equation, we have y plus xp square the whole square equals to 4p square x square. Now say this is equation number 3. Now eliminating p from equation number 2 and equation number 3. So this y as it is, and you can see that p square x that is c. So replacing p square x by c, so it will become y plus c the whole square, and that is equals to 4, and the value of p square is c by x into x square. So one time x will cancel out, the result is 4cx. So this is the general solution, that is y plus c the whole square equals to 4cx. Okay. Now we will see example number 2. We have to solve y equals to x minus ap minus p square. Say y equals to x minus ap minus p square, that is equation number 1. Now differentiating this equation with respect to x, so it will become dy by dx, and dy by dx is p. Now applying product rule on x minus a into p as it is, and derivative of x is 1 and a is 0. Then after plus x minus a as it is, derivative of p, that is dp by dx. Then after minus derivative of p square is 2p, and again multiplied by derivative of p with respect to x, that is dp by dx. This p and p will cancel out, so we have 0 equals to x minus a dp by dx minus 2p dp by dx. Now taking dp by dx common, into bracket we have x minus a minus 2p. Now you can see that the term of dp by dx is absent in this particular term. Okay, so neglecting this second factor which does not contain dp by dx, so we have dp by dx equals to 0. So integrating both sides, we have p equals to c. Now substituting this p equals to c in equation number 1. This is equation number 1. So replacing p by c, we have y equals to x minus a into c minus c square. Okay, so this is the required general solution. Now we will see case number 3. Equation soluble for x. Example number 1. Solve p square minus xp plus y equals to 0. Say this is equation number 1. Now making the subject of x, that is x equals to p square plus y divided by p. Now say this is equation number 2. Differentiating this equation 2 with respect to y. So derivative of x with respect to y, it will become dx by dy equals to divide p square plus y by p. So first term will become p square over p, so it will be p, and derivative of p with respect to y, answer is dp by dy. Then after plus y by p, and we have to differentiate y by p with respect to y, and for that purpose we will apply divide rule for differentiation. So p will be as it is, multiplied by derivative of y with respect to y, answer is 1. Then after minus y as it is, multiplied by derivative of p with respect to y, that is dp by dy, and divided by p square. Now you know that dy by dx is p, so dx by dy is 1 upon p, and that is equals to, now we have to simplify this equation. P over p square result is 1 over p, and we have dp by dy, then after minus 1 over p square into y into dp by dy. Now taking dp by dy common and p square LCM, so after simplification we will be having this term p square minus y over p square into dp by dy. and this plus 1 over p will be as it is. Now 1 upon p and 1 upon p will cancel out. We have p square minus y over p square into dpy dy equals to 0. So we have to neglect the first term as it does not contain dp by dy. So we have dp by dy equals to 0. Now integrating both sides, integration dp by dy equals to 0. So we have p equals to c. Now from equation 1, we can see that equation 1 is p square minus xp plus y equals to 0, and the value of p equals to c. So replacing p by c in equation number 1, we have c square minus cx plus y equals to 0. So from here we have y equals to cx plus y equals to cx minus c square. So this is the required general solution. Now example number 2, we have to solve this differential equation xp square minus yp minus y equals to 0. See, this is equation number 1. Now making the subject of x from this equation, so we have x equals to y common, into bracket we have 1 plus p and divided by p square. Now see, this is equation number 2. Now differentiating equation number 2 with respect to y. So derivative of x with respect to y, result is dx by dy, and that is equals to, we will apply product rule on this function. So 1 plus p over p square as it is, and derivative of y with respect to y, result is 1. Then after plus y as it is. Now we have to differentiate 1 plus p over p square with respect to y. So we will apply divide rule of differentiation. So p square will be as it is into differentiation of 1 plus p with respect to y. So derivative of 1 is 0 into derivative of p with respect to y. So we will be having dp by dy. Then after minus 1 plus p will be as it is, and derivative of p square, that will be 2p into dp by dy, and we have taken dp by dy common, divided by p square the whole square, so it will become p raised to 4. And we know that dy by dx is p, so we have dx by dy equals to 1 over p. Now dividing 1 plus p over p square by p square, so we have 1 over p square plus p over p square, so the result is 1 over p. Now we have to simplify this result, taking p common, and one time p will cancel out, so in the denominator we will be having p cube, so it will become p minus 2 minus 2p, minus 2p plus 1p, it will become minus p and minus 2. This dp by dy and y will be as it is. Now 1 by p will cancel out. We have dp by dy equals to p over 2 plus p into 1 over y. We have simplified this term and this term only by taking p cube LCM. After simplification, we will get this result. Now applying the concept of variable separable form, so it will become 2 plus p into dp by p equals to dy by y. Now integrating both sides, integration 2 plus p over p dp equals to integration dy by y. Now integration of 1 over p, answer is log p, 2 will be as it is, plus p by p is 1. So integration of 1 with respect to dp, answer is p, equals to integration of 1 over y, answer is log y, and taking minus log c as a constant value, it will become log p square plus p multiply by 1, writing 1 as log e plus log c equals to log y. Now this is log p square. Applying the property of logarithm, it will become logarithm of e raised to p plus log c equals to log y. Now again applying the property of logarithm, it will become logarithm of c into p square into e raised to p equals to log y. So from this result we have y equals to c into p square into e raised to p. Now put this value of y in equation 2. See equation number 2, that is this one. Okay, we have to replace y by this value. So x equals to cp square into e raised to p into 1 plus p over p square. So one time this p square will cancel out. We have x equals to c into e raised to p into bracket 1 plus p. So this is equation number 4. So equation 3 and equation 4 together constitute the general solution. Okay. Now we will see Clairaut's equation. An equation of the form y equals to px plus function of p is known as Clairaut's equation. And the solution of Clairaut's equation is obtained on replacing p by c. So the general solution will be y equals to replacing p by c. So it will become cx plus replacing p by c. It will become f of c. So this will be the general solution. Now we will see some examples related to this topic. We have to solve this differential equation y minus px into bracket p minus 1 equals to p. So the given equation is y minus px into p minus 1 equals to p. So y minus px equals to p over p minus 1. So making the subject of y. So y equals to px plus p over p minus 1. This is Clairaut's form. Hence the general solution is given by replacing p by c. So we have y equals to cx plus c over c minus 1. Now example number 2, we have to solve this differential equation. P equals to logarithm of px minus y. So the given equation is p equals to logarithm of px minus y. So writing it in an exponential form, we have e raised to p equals to px minus y. Now making the subject of y, so we have y equals to px minus e raised to p, which is a differential equation in Clairaut's form. So its general solution is given by replacing p by c. So we have y equals to c into x minus e raised to c. Thank you for watching this video.